Japs call it the bullet, and it looks like a bullet, this super express that thrusts aside all existing ideas of train speed.
High-speed rail has been a popular choice for long-distance travel since Japan's bullet train started service in 1964. It's common across Europe and Asia, thanks to the high population densities and city networks that are present there. But railroads in Canada remain quite a bit different. That train is the same one we use today. The only difference is that between then and now, travel times between Montreal and Toronto have increased by an hour. Yet Canada did have a brief experiment with high-speed rail in the 1960s. The CN turbo train used plane engines to reach a top speed of 274 kilometers an hour, but it didn't last long.
The turbo train was withdrawn from service for engineers to iron out a number of teething troubles.
High-speed rail functions best when it runs between major urban centers, usually between 150 kilometers and 800 kilometers apart. This is what we see in Asia and Europe, like between Paris and Lyon, or Shanghai and Beijing. But in Canada, stations are far too closely spaced to really take advantage of high-speed rail. On top of this, tracks must be dedicated to passenger service. Freight trains cannot take priority over passenger trains. If these conditions are not met, high-speed trains will not make sense for passengers. When it comes to station sites, downtown sites are best suited as they serve major tourist and business populations that travel from core to core. A study in Italy found that the denser the high-speed rail network, the more local and global tourists were attracted to it. In Lyon, the new service at Parc-Dieu led to a major commercial and office development that is now a central core for the entire city. While this potential also exists for stations in suburbs, poor land use planning can result in increased sprawl. The key to maximizing the land use potential around either station site is to increase density, avoid surface parking, provide easy transfers to local transportation, and create a high-quality public realm. The most important land use consideration for high-speed rail is that it creates tunnels and islands. Tunnels are long corridors where accessibility is not improved and land use is not intensified. In the case of a replacement of conventional rail systems, both these conditions may actually be worsened. It is also along these tunnels that most of the expropriation and nuisances associated with high-speed rail will be concentrated. Islands surround stations, and they concentrate improvements to accessibility and the intensity of land use. High-speed rail can perpetuate core periphery inequalities by design. Canada's national passenger rail service, Via Rail Canada, insists high-speed rail is not worth the investment. Via instead looks to service the small population centres between Canada's largest cities, which will likely not result in the level of tourist and business activity the high-speed rail would create. In the end, Canada's choice on expanding passenger rail service should consider the land use and development potential that high-speed or conventional rail will unlock. Is our priority to centralize investment and minimize travel times to Canada's major urban centres, or is it to increase accessibility to these markets for rural and small-town populations? While Canada may have lost the lead it had with the turbo train for high-speed rail, it still stands to gain from either approach it takes.